first session. Today, we're gonna introduce Christopher. He's a data engineer from Microsoft, and I have been really looking forward to this session, Christopher. So, welcome.
Hey, thanks for having me.
Thank you. So, Christopher, you're gonna kick off our event here, and you can say you're gonna talk about something that is extremely relevant to the entire IoT spectrum, uh, being how to use IoT data, right?
Yeah, we'll see that there is different ways to creating value from deploying an IoT solution. And one of the big way of creating value out of IoT is by actually using that data. And we all know that the IoT is actually generating a ton of data. The issue is when you have this data produced by your IoT devices, how do you make it useful and how do you make it across useful across your entire set of application and services for your customer, your employee, etc.
Yeah, couldn't be more relevant than what we are talking about at this conference. So, with that, Christopher, I will give the word to you. All the best.
Thank you. Hello, everybody, again. So we'll see today how to go from IoT data to what I call meaningful data, which is data that is in context and used across your line of applications. So my name is Christopher Mano. As we said, I'm a data engineer and advocate at Microsoft. If you have any questions, you can just send it to me through the chat interface, and we will have a chat in time at the end of the presentation to answer your questions. You can also ping me on Twitter or LinkedIn if you have any question after that, or if you are watching the recording and then you have some questions, do not hesitate to contact me. And a last item before I start my presentation, you will get access to all the slides, so sit back and hopefully enjoy this presentation. So, as I said in my kind of introduction, the value of IoT deployment come from two big different things. So, first one is what we call the cyber model, which is the ability to, when you have an IoT appliance, to change the way it's function internally from a distant range. Let's take a concrete example. Let's say you have a dishwasher, an IoT connected dishwasher. You may think that it's not really so useful. It's just a dishwasher. Maybe it can send you a phone notification when you can empty the dishwasher, but there is not a lot of interest in having an IoT dishwasher today. But then the COVID hit, and the only way to get a clean, COVID-free, clean dishwashing program was to run like the highest program in your machine, and maybe working in 90 degrees, heating the water to 19 degrees for the entire duration of the cycle. It consumes a lot of water and it consumes a lot of energy to warm up all this water. But if it's an IoT dishwasher, the manufacturer can actually create a new program, a COVID specific program, but maybe we not eat up to 90 degrees for the entire duration of the cycle, but could be 2 or 3 hours, but only for 15 minutes, because maybe 15 minutes at 90 degrees is sufficient to kill all viruses and bacteria. And because it's an IoT dishwasher, they can send out this program and actually changing the way your dishwasher is working by providing new feature or an added value. Here, the added value is less water consumed and less electricity consumed. So you can now have a new feature with less cost. That's one of the values of things we can get with the cyber model. Obviously, the cyber model is not something you can apply to all your IoT devices. Today's in the IoT real world deployments, we have a lot of deployments, a lot of IoT appliance and devices that just emits data that are not connected to anything physical, to what we call an actuator. For example, we have like a water flow sensor. We have temperature sensor. In France, we are deploying in classrooms a lot of CO2 sensors to ensure we open up the window frequently through the day. So all these kind of sensor that just emits data to some endpoint uh, will not benefit from the value created by the cyber model, but they can benefit from the other aspect of IoT deployment values, which resides in the analytics, which is you got a ton of data, what you can get out of this data. And the fact is, when we look at real world deployments again, most of this are just for like displaying some number on a dashboard. And I think that we need to move forward. And most of the time, some business unit in your organization deploy some IoT sensors, and then they reuse that sensor for one single dashboard. And all this data is kind of it's in silo. Like there is the IoT data in a way, and there is a CRM data in another part of the organization with another database, and nothing communicates. So we will see how we can make this IoT data more meaningful, and we can do it with some basic principle. The first one is by enriching the data. For due to the lot of constraints we have on IoT devices, and especially on the network between IoT devices and like central IT or the cloud, most of the time IoT devices send very little information about themselves. Like we may have one device ID and one temperature and one air pressure, and that's it. So sometimes you will need to enrich this data to make it useful for the company. With context data, for example, you can have a CO2 sensor that is connected to the city weather service, and so you can know if there is a lot of wind. Maybe we need to open up the window a little bit less because the wind will blow inside the classroom and will refresh the air uh, yeah, at a more frequent pace. So maybe we need to connect this IoT data with other sources of data, or you may need to enrich this data with what we call reference data. For example, maybe the device sensor ID is not really useful. It could be a GUID, it could be some random number. It doesn't give you context. But if you have a database of all the sensors you have installed and which is building the floor, maybe the room where they are installed, then you can start doing a lot of different things. But most of the time, all this reference data, all this context is not really sent by the device itself. Uh, Second thing, which is I think where we need to progress more as an industry, is making this IoT data accessible, accessible to businesses, databases, to data engineers, to data scientists, and to business applications. And I will show you a few examples of that later during this presentation. And sometimes, but it's not like a rule or a golden objective, make it real time. Um, Again, I saw a lot of projects like try from the ground up to build a real time stream of events coming from IoT devices. Um, and it's actually complicated. It's a lot of work to make something real time in IT, and most of the time it will not provide so much value compared to other way of doing things. Sometimes it could be meaningful, but to have this data at real time, sometimes not really. I'm sure you're probably familiar with the nature of IoT data, but for those who are not, I will briefly show you what kind of data we need to manipulate when we are manipulating IoT data. So, first type of data we had is JSON documents or formatted document in another format than JSON. They are quite structured. We know how to parse them, and we have some information about device, about time, etc. We most of the time have, as I said, some metadata, like the device ID. We can have like the customer, if you're building a solution for your customers, like a SaaS service for IoT, you will probably have other type of data associated with it that may reside in another database, and you need to like assemble these two things into one document at some point. And as I said, we can have context data we gather from other sources, like my weather example. But we also have more and more unstructured data. And I saw in the program, I think we have a later today a session about Azure Percept. We will probably see some live video feed in this session and analyzing live video feeds. There is a ton of application about it, from answering safety of workers to counting the number of people. Um, there is a lot of things to do based on live video feed images, audio streams, etc. And this kind of data is unstructured, at least at some point, and may present some challenges for the analysis. So now we have seen the nature of IoT data and why we need to think about it to really create value out of our IoT solutions. Let's say the first step about enriching IoT data. So if we take a look at a very basic IoT architecture, we have somewhere our devices. Nowadays, most of the devices are connected to what we call a cloud gateway, which is basically a central communication point where all your IoT devices are communicating through this central gateway, and all your downstream application are getting the data from the IoT devices from this single point. In Azure, we have a service called Azure IoT Hub that acts as a cloud gateway. And at the other part of the spectrum, you have some user that want to see this IoT data somewhere. Maybe in Power BI, which is our data visualization tool, maybe in a business application, as I said before. And the first question we have is, where do we store all this incoming data? In which format, and where do we process this data? Like enriching the data, do we store it before or after enrichment? That kind of questions. And we have a lot of services for doing this, and a lot of architecture we can put in place. I will show you some components, and obviously, depending on your project and constraints, you may have to change your components. I will also talk a lot about the Azure services, but again, you can use other kind of services on other platforms, depending uh, on your requirements. You should be able to take this schema and use it elsewhere. So most of the time in the existing applications, we have some kind of relational database. We heard a lot and a lot that relational databases are not meant for IoT data due to the volume of events that need to be processed, and the stored duration, which is uh, associated with the volume and velocity. Usually outgrown relational databases. We'll see that it's not really the case, and we can still use an classic relational database like Azure SQL to store IoT data in some cases. But most of the time, what we want to do is to store the data before the enrichment. So really storing the raw data for future references. And for that, most of the time, we will use data lake, which is a great way to store a massive amount of data in an unstructured way, yes, but at least you have all the data available. For example, for some data scientists that may join your team in the future and that may need to have access to the raw data. So we'll see how we can store easily raw data from Azure IoT Hub into Azure Data Lake. And then you may want to store process data. So you will take the data, the raw data from IoT Hub, you will enrich it with some metadata, and you will store it in a relational database. So you can do it in Azure SQL, in PostgreSQL as well, or you can use one of our newest service in the analytics space, which is Azure Synapse Analytics, which is In a way, it's Hadoop for people who don't want to deal with Hadoop and just want to deal with SQL. I will show you an example of what is Synapse Analytics in a few minutes. Um, so how do you connect all of that? You will need to have a way to process data um, in real time or in a small batches of few minutes. And we have a managed service for that, which is Azure Stream Analytics, that allows you to take the data, to consume the data from IoT Hub, to enrich it to some extent, and to store it to different destinations, including Azure SQL and Azure Synapse Analytics. So one thing you need to think about uh, if you want to store in a classic SQL database is, as I said, the velocity of the number of events you need to store. One IoT device, if it's connected to a wired internet, can send dozens of events per second. But you will probably not want to store this dozen of events per second in a SQL database. Maybe the granularity you need is something like one line per device per hour. And this is something that Azure Stream Analytics can help with. You have what we call windowing functions that allows you to, for example, compute the average of temperature for every device for every hour, so consuming like hundred of events in the input, but only outputting one event per hour. And that's why you can totally use a classic Azure SQL database for storing IoT events. And this is something really important if you go back to how we make IoT data meaningful. One of the things is making this data accessible. And one of the way to make this IoT data accessible is to add it to existing a database used by business applications. So sometimes you can do something very easy, even for your like software development teams, if you're developing in-house business softwares, to make this IoT data accessible. They don't have to understand Kafka. They don't have to understand Hadoop to get the benefits from this IoT data. You can simply create a stream analytics workflow, and they can have their IoT data right within their database. But sometimes a very easy way to give access to this IoT data to a lot of business applications. So as I said before, we tend to store the raw data coming from IoT Hub directly into Azure Data Lake. The issue with that is it's in a raw and unstructured format. So anybody who would want to use that data with a fine granularity, we need to actually redo all this enrichment process. And if you have dozens of internal application that want to benefit from that data, that means that you will need to redo this enrichment a dozen of times, maybe in different languages with different teams, and so with probably a difference in data quality at the end if you need to re-implement these processes a lot of time. So when you're using a data lake, sometimes you have two types of data in the same data lake. You have the raw data for, as I said, specific exploration, for legal purposes if you need to store the raw data for whatever reasons, etc. But you also have clean data stored also in your data lake. And between the two forms of data, you will have a process. In this case, we will not be able to use Azure Stream Analytics. As the name is saying, Azure Stream Analytics is only working on a stream of events and not on like stored data. But you can use tools like Azure Data Factory or the pipeline within Azure Synapse Analytics or notebooks within Azure Synapse Analytics to process the data coming from the data lake and storing the result of this data, maybe enrich, maybe clean data directly into, again, Azure Data Lake. So I wanted to uh, do a quick demo about what we can do in this space. So let's switch to my Azure subscription. Hopefully, you're being able to see my screen well. And I have a bunch of things in that resource group, like in that project in Azure. I have an IoT hub, which is, as I say, the cloud gateway. So all the messages coming from the IoT devices are sent to the IoT hub, and then the IoT hub will duplicate this messaging to a lot of different downstream services. And I also have some Docker containers running to simulate an IoT device's activities. So everything is in the cloud, and for this demo, I don't have actual real devices. It could be easier if you want to generate a lot of data. Like I can have dozens of fake IoT devices sending data instead of having only two or three boards on my desk. And I have other services we will show in a minute. And the other one I wanted to show you is the storage account, which is my data lake. So basically is a huge hump of storage where I can store terabytes of incoming data in not a structured way. So the first thing we wanted to do, if you look back at my architecture, is storing the raw events coming from the IoT hub directly to my data lake. And the fact is, this is something which is built in within Azure IoT Hub. With this message routing function feature, I can add a data lake storage connection, data lake storage endpoint, and then I just have to create a route to redirect all the messages received from the devices to my data lake. So this first part, like storing raw data, is out of the box. Really, is just one click or one command line or full line of infrastructure as code to make it work. So this first thing is quite easy. The second thing I have in my repository in my project is this Stream Analytics job. So Azure Stream Analytics is really a cool service when you want to do like simple integrations, even with enriching the data from one event stream to out to some kind of database. Um, Azure Stream Analytics is really simple to use because you have basically three things to know. So first thing is the input. So where my data is coming from. And as you can see, you can have Event Hubs, IoT Hub as an input, and you can also have reference input, reference data. That means, like for example, as I said in my example, maybe your IoT device is just sending a device ID. And what you want in your output is like the device ID, the building where the device is installed, the date of installation, that kind of things. And this other information is stored in a classic SQL table. Then you can load that table into Stream Analytics, and you can join the string data and this reference data to a single output. So let's switch to the outputs. And as you can see here, I have only one output for this job, but it's sending all my data to a SQL database. That's it. But Stream Analytics support different type of outputs. It could be another function if you want to do advanced thing like writing your own code to connecting to something specific, or for example, if you want to make some advanced calculation and then sending an alert, maybe you can do it with Azure Functions. You can just store this data in Azure PostgreSQL, Synapse, Blob Storage again, so the data lake, same thing, Cosmos DB, or SQL database or table storage. You can send it to a real-time Power BI dashboard item, which is something very cool. If you want to do real-time, it's probably the easiest way to get started. You just need a Power BI workspace and a Stream Analytics job, and then you can compute in real time and display in real time data without having to code anything. Which I think it's very cool. And especially when you're beginning your project, you don't really know what kind of indicator, what kind of KPIs you will need in real time. It allows you to prototype things very fast, including on a real world IoT project. So maybe you already have deployed IoT devices. You can just create a Stream Analytics job for dumping the real world events coming, but sending it to like a development Power BI dashboard to just understand what you need to create. And you can send it to another queue, so outputting an event, but again, maybe enriching this event with some metadata. And how do you connect the input and the output? It's very easy. You just have to write a SQL query. So in this example, as you can see, I have one input, which is the IoT hub, one output, which is my SQL table. And I will just select three fields from this IoT hub into my destination database. Um, Here you have a very, very simple query, as I said, but you can make query more advanced, like by using windowing function, which means you will make an average or sum of something over a specific time period. Um, you can join things. So if you have a reference data, you can join data from your reference table and your event feed into one single object. And you can test everything in here. It's not working right now because my simulators are down, so I'm not generating any data. Uh, but you can, if you have actual events sent to your IoT hub, you will be able to see them here and to test your query right within the Azure portal. So um, this is a very, in a sense, it's a very simple piece of software, but just this allows you to really push your data, your IoT data, to different type of application and services like Power BI, a lot of existing databases that may be used um, by your current business applications, allowing you to effectively make this IoT data available to a lot of applications that do not talk IoT, that do not talk IoT at all. But we can do more in making this IoT data accessible to a lot of different people, roles, application services. If we take a look back to who needs to access the IoT data and what kind of IoT data is needed, uh, what I saw in my different customers is we have different typology of users. We have developers, we have data scientists, we have data analysts slash business analysts, and we have obviously the end users. And all these different roles do not need the same type of data, and they do not use the same type of tools. Maybe a developer is interested in like having the raw events, and they can hook up to IoT Hub. They can create an Event Hub's consumer program, but not a big deal. Maybe they are not into IoT and real-time systems, and they will prefer, as I show you in my previous demo, to simply have a SQL table populated for them, and they will happily query this SQL table, and that's it. A data scientist, most of the times, they need to have access to, they need to have access to the raw data to be able to work on some machine learning algorithm. The data business analysts, they don't need the raw data. They need like pre-calculated data, most of the time aggregated to a certain range, because they will analyze things year over year or month over month. They don't need like a second resolution for analyzing data. And the end user, they want something which is meaningful to their business. They probably don't want the raw data. They will probably also use either business application, Power BIs, or even Microsoft Teams. They will not want to query something specific. They want to have something that is really easy and that provides value to their business, and probably in context. So it may be in a mobile application, or it may be in uh, a web page, or it may be even some display within a factory floor displaying critical informations. So how do we make this IoT data accessible to all these different kind of user and across all these different tools? So I already show you previously how to make it accessible to a SQL database and to a data lake. So the data scientist needs could be covered in a way, and some developers needs could be covered as well. Um, as I said before, one of the way to make this IoT data accessible is to simply use Power BI. Power BI is more and more used in organization of all sizes to create reports, display dashboard, etc. Here you can see a dashboard I've created few months ago, even a year. About a dashboard for public school. So you can see some student achievements graph. There is the menu on the left, and at the bottom, you can see air quality data. And if you look at how I made this dashboard, I've actually used different type of data sources. There is like a classic database, a PostgreSQL database on the top. There is a Power BI application, a Power Apps, sorry, application on the right. And for the air quality, I use two type of data sources. The first one is the stream analytics job, sending data to a SQL database, which is based on an alert. So in that case, my stream analytics query is not like grouping a bunch of events together to create like one event per hour, but it's more like, okay, if if the average of the last five events are above a specific threshold, then I output an event and I discard the other ones, which is also something you can do really easily to stream analytics. So I've created a SQL table containing all the alerts. If the CO2 reach a specific threshold, then you create a new line in my SQL database. And for displaying the graph of history, I'm using another service, which is Time Series Insights. Time Series Insights is a time series database. So it's basically a database that is optimized to store and process and display data in a time series. So it's a very efficient way to query a lot of data with a lot of resolution, very small resolution up to the second, and you can process very large amount of data in seconds really. One of the other things you can do, as I said, when you're thinking about where your IoT data could be useful, think about the tools that your user are using. And if I'm talking about a teacher, which is the case in that demo, I don't think the teacher will connect every day or twice a day to a Power BI dashboard to see the air quality. This teacher have a lot of different things to do, including managing the students, managing the homework, maybe managing the parents that have questions, the administration, etc. They don't have time to look at dashboards to understand if they need to open the window at some point in time. Obviously, you can have right on the IoT device like a flashing light showing things. But if there is something that is bit more important, but something that could be decided from just one device, but by need to be processed or data that need to be aggregated across a range of devices to provide an alert, maybe sending the alert directly to Microsoft Teams or to another messaging software is something that could be really useful. And what you see in the screen here, it's a simple alert, but has been sent to a specific Microsoft Teams channel from a Logic app. A Logic app is a service within Azure that allows you to create workflow in a visual way. And I've connected this to Azure Stream Analytics. So Azure Stream Analytics is doing all the querying work across the events to detect if we start to have a series of events that cross a specific threshold. And if it's the case, it will kick off an logic app. And within this logic app, we will design this card and we will display into Microsoft Teams. Again, all of this demo has been done without coding anything. So I wanted to go back to my little architecture here, and as you can see, with the last different slides, we've added a lot of different services to the mix, from time series insights to Microsoft Teams and Logic Apps, to Power BI, and to stream Synapse Analytics. I wanted to give you a quick demo of Azure Synapse Analytics to show you how we can use it to, again, without having a specific knowledge of IoT, how we can make this IoT data accessible. So let's switch back to my resource group, to my project. And as I said, I'm pushing all these events directly to this data lake. And I have here my Synapse workspace. So if we switch um, to my Azure Synapse project, here is it. Um, the first thing we want to do is to query the raw data stored in this Azure data lake. And this is something you may want to do like early in a project. You may have like no data scientists yet. You may have started to work on like the IoT devices and connectivity part of your project, but you don't really know how to make this IoT data useful for the customers. So you've started to pour all these events into a data lake, and then you're trying to make sense of what you can do with all this new data. One of the cool things of Azure Synapse compared to a lot of other tools in the market is you have a serverless offering, which means that when I will execute this query, I can execute this query across terabytes of data without having to spin up a cluster, without having to pay for this cluster every month. But I will just pay by the number of terabytes of data scanned. So if you're just getting started in analyzing a large volume of data and you don't have like prior knowledge or expertise in things like Hadoop or distributed databases, that's a great way to get started. You're writing SQL code that should be fairly easy for a lot of developers or data engineers, and you don't need to think about really how your data is stored. It's just a JSON file stored in a storage. So we can explore this raw data here from the data pane. Um, and my raw data is in this container. And as you can see, I have the name of my IoT hub, my cloud gateway. Then I have some numbers. It's a partition thing, is a way we can store a lot of data. And then we have a hierarchy with year, months, day, hour, and then minutes. And we have one JSON file uh, per minute. And if I preview it, as you can see, I have a lot of, actually, it's one JSON document per line. We can really cannot see the line feed here, but there is one JSON per line. So here is line 1, here is line 2, etc., etc. But when we analyze this data, we want like a query with a table as a result and not really a JSON document. And one of the cool things of Azure Synapse is, thanks to this open row set feature and the JSON feature ported over from Azure SQL, we can analyze very easily JSON data without having to create a database schema and without having to import any data into a specific table. So here, if I launch this, it will take a few seconds, even if the data set is not so large in this case, because it's, as I said, it's a serverless, so it's actually fetching an available cluster for me, sending the job, and splitting the job across a number of servers. Each server is executing part of the job, and then all the data are aggregated onto one single server and sent back to me. So here I have the result of my query, and you can see the raw data, which is coming from hundreds and hundreds of JSON files across this data lake in a classic table format. I can chart them, so I can see if already I have some outliers. And just that, like with few simple SQL queries when you're getting started, and again, without paying like a monthly fees, you're paying per request, per query. You can really get a sense of what is your real world data, and maybe starting to see where you can learn this data in a meaningful way. So I can do other things, for example, computing here the the average temperature per device. So as long as I have started to parse my JSON data, I can start using like the classic SQL feature. So I join two tables between them. I can compute average, groupings, etc. All of this is accessible. Um, that's one side of the equation. Querying this raw data is interesting at the beginning, but at some point you will need to like make something more architecture and create some tables, and you need to tell to some people here if you want to have access to this data, like we got um, the results are back, so here I can see the average temperature of the different devices. But as I said, at some point in time, you will need to structure things, to industrialize things, to create tables, so other processes and other applications will be able to use that. And the fact is, there is another side of Synapse. You can create a Synapse pool, like you're creating an Azure database. So in this case, you will pay as long as your pool is up and running. But you can have like real tables. The only caveat is, as you can see here, I have device, measurement, and room table. The only caveat is these tables are not really stored in a classic way. We are decoupling the way the storage is done from the CPU and the memories from the compute part, which means that in this instance, the device and room tables are tables that are of reference data, something I need to aggregate or to analyze data. These two tables are actually duplicated in each node of my cluster, while the measurement table is actually splitted. The data is splitted over all the data lake, um, and I can do interesting queries. So, for example, here. Um, let's try to find if the average temperature of a building is above 8 degrees and the number of devices from this bundle. And as you can see, I've executed this query over dozen thousands of lines with a few seconds, even like 2 seconds with back and forth from my computer in France, back and forth to the cluster. So it's a very easy way to get started to do things that we tend to do with something like Hadoop, like a distributed database and jobs, etc. But you don't have to learn all of those things. So the API that is exposed to you as a developer is almost just SQL. There is a few things to know, like to create some different reference or data tables, but you can get it started very easily. And remember when I said that um, my job here, my stream analytics job, was outputting something to a SQL database. In fact, is not sending data to a SQL database. It's sending data to a Synapse database, which means that if you have an application that can talk to a SQL Server, they can actually talk to Azure Synapse. It's the same driver you can use across the two types of databases. But Synapse is way more than just a database or just a way to query the raw data. As you can see here, I don't know if some of you have spotted this, but here it's directly connected to my GitHub account, which means that all my scripts, for example, these two very silly, simple scripts to query data uh, from the data lake or for Synapse query, are in fact um, part of a sorry, I'm losing my words. Uh, Part of workspace, and they are pushed directly into a GitHub account. So I can have access to all of this, and I can share this from Dave branch and May branch across the different developers in my project. So it's really an integrated environment for creating data. And you can also, but I'm running out of time for this demo, do the integration part. So you can create a pipeline and copy data from one database to Synapse, or from Synapse to another database as well. And if you want to do more machine learning things, you can also create notebooks or Apache Spark work right within Synapse. Um, my role at the end is Synapse is a great tool to get started with getting access to a lot of data because it's just SQL. And you can start manipulating terabytes of data with the simplicity of SQL, and while connecting your business application to Azure Synapse Analytics, because from their point of view, is just SQL. So let's switch back uh, to the slide. Um, so yeah, getting meaningful data is could be a lot of work, but it's also how do you think about exposing your data to different business application and business services, either by using tools like time series insight, like logic app, to expose to business application like Power BI or Microsoft Teams, or to directly expose this IoT data to business application by simply leveraging this how this existing application are using data, where they are getting the data from, and they are getting the data from most of the time from classic databases, from relational databases. But with few tools like Azure Stream Analytics and Synapse, you can get them access in their way to this IoT data. I hope you enjoy this presentation. Again, you will be able to access the slides at this address, manu.org/iot-meaningful-data. I think we can copy paste. I will copy paste the link in the chat in a few seconds. You can follow me on Twitter. And now we have time to answer your questions.
Well, thank you so much. That was really good, really insightful. So, really great. So we have gotten a handful of questions for you, and one of them that it's a straight on question: is ADX meant to replace TSI? So yeah, I guess
Yeah. So first, I will unbundle the acronym.
yes,
If you're in Microsoft Space, you know we are in love with acronyms, unfortunately. So TSI means Time Series Insights. I briefly touched about Time Series Insights in my presentation. And ADX, I think John is talking about Azure Data Explorer.
I guess so
Um,
too. Yeah,
yeah. Uh, so no, it's two different products that don't serve the same purpose. Um, I can understand that there is an overlap between them, but time series insight is at the core as something for time series events and for analyzing them. So you can do things like analyzing the last 15 minutes compared to the 15 minutes before that 15 minutes. You can do things like that. You have a very simple query language in time series insights, so it's really like for telemetry events, for metrics, not for telemetry events, for metrics, or for discrete numbers from IoT sensors. Time series insights could be really interesting, and the fact that you have an API in time series insight, so you can, I haven't showed it, but we even have a JavaScript SDK for time series insights that allows you to integrate time series insight data into your own application. So time series insight is for that. Azure Data Explorer is more for what I called warm data. So maybe you have heard about the Lambda architecture, like the hot path and the cold path. So basically, the hot path is analyzing data almost in real time, uh, something we can do with Azure Stream Analytics, for example. And the cold path is you store everything in the data lake, and then you have some batch processing that analyze that cold storage. Um, but there is a gray area between hot path and cold path, which is a warm path, which is maybe you need a little bit more history that 1 hour, because in hot path you're kind of limited by the amount of RAM, of memory you have in your streaming engine. So you cannot analyze like 2 weeks of data in the hot pass. But maybe you need to act a little bit more quicker that one a batch job can do. Here is the area of the warm path, and Azure Data Explorer is in Azure at least the perfect tool for analyzing with warm paths. You can ingest data very quickly in Azure Data Explorer, and you can query it very easily. Um, and a side note about Azure Data Explorer: Azure Data Explorer is at the basis of a lot of our internal analysis. So when we want to analyze the performance of a specific feature on Azure, on Office, on Windows, it's all in an Azure Data Explorer cluster. So it's not going away. Azure Data Explorer is not going away, and Time Series Insight is also used in a lot of Microsoft products, internal products and internal tools. So from what I know, it's not going away either.
Okay, and actually speaking of all of these services, we got a question from Torben asking how to get an overview, how to know when to use which service. Yeah, besides of course asking consultants like me, but
Yeah,
other
it's
yeah.
it's it's a complicated it's complicated story. Like there is a lot of different Azure services, and even within the services themselves, there is a lot of differences the way you're deploying it, etc. For example, I thought about Synapse serverless offering and Synapse pool offering, which are two different things into the same product. Um, and maybe Synapse serverless is as best suited for your work. But if you're not using Synapse Services and Synapse Pool, maybe there is another service in Azure that is kind of between them and better for your use case. Um, we are working on getting some overviews. For example, we are working for Microsoft Learn. So docs.microsoft.com/learn, which is an online free learning platform. We are working on a series of videos about the data, what you call the data fundamentals, um, just to give an overview of a few things. But there is a lot of different services, and when we talk about data, like dozen and dozen of services. Uh, so yeah, I would say explore the Azure.com website. We try to categorize all of the services into well-known categories, and just read the overview page of all of the services. Um, and after, yeah, if there is any other question, something that is not clear, or an introduction that is not clear to a service, feel free to ping me. We can fix the Azure.com webpage. But we don't have we're also exploring sketch notes. One of my colleague Nitya is doing a lot of sketch notes. She has done one of them for at Microsoft Ignite event for IoT. We're also exploring this as a way to summarize things, but yeah, there is a lot of work to do ahead of us for my team in uh, getting this overview out.
Yep. All right. Time flies, and I have a final question for you,
Yeah.
and it's not a small one. So, how do you see the future of IoT?
Uh, g- Great question. And I only have less than 5 minutes.
Yes.
Uh, I think there is a huge potential ahead of us for the IoT space um, in a lot of different areas. But we have a few challenges. I think we have three big challenges ahead of us. The first one is providing value to IoT. That's obviously why I created this presentation. And there is a lot of things to say about the cyber model, like the other part of the value creation. But it is something I see a lot of different IoT projects being created more because it's actual and they know we can do something with it, but without having a clear value creation proposition from the beginning. That's the first issue. The second issue is standardization. Um, when you have like 10 IoT devices in a factory floor from 10 different manufacturers, they do not communicate the same way. They do not communicate even simple temperature, simple things like temperature in the same way, in the same format, etc. So integrating a lot of different IoT devices from the market, because a lot of companies are creating IoT project without creating their own device. They are just using some existing device on the market, like a LoRa one or a fluid detector, a water flooding detector, but assembling all of us into a single point, so all the developers and data team in the company are using a single way, in a structured way, it's the same information like temperature is across all the devices is displayed in the same way. That's a huge issue. We are trying to do things with the DTD and some Azure services, but um, it's like IoT plug and play, that kind of things. We are trying to create ways to create specification, so the IoT device advertise to the server what kind of information they provide and how they're providing it. But we are far from reaching that goal. And the last but not least issue we'll have to face is I see a lot of IoT projects with hundreds of devices, but when they want to cross and to go to 100,000 devices, there is a lot of projects that stop here, but don't go to the full production phase and deploy to what the initial plan was. There is a lot of delays, obviously, with all the constraints we have, including on the hardware parts, hardware supply chain, etc. A lot of projects are delayed, but scaling these projects out of like a prototype phase or out of yes, so we have done this in one factory, but we have 100 factories across the world. Let's get this project into all these factories. Crossing this part is is getting a lot of challenges that few companies are tackling.
Christopher, uh, great insights into to the future, and no doubt about that. Uh, Something like standardization is something that needs to be taken care of before IT can really be broadened the way
Yeah.
we hope that IT will. And with that, Christopher, a big thank you. It really has been a pleasure to have you here at the conference. Thank you so much. I know that your slides will be shared afterwards, and the recording will also be available online. So, with that, thank you so much.
Thank you for listening to
Our
me.
next,
Enjoy the
thank you.
conference.
Thanks. And our next session is coming right up. And all you need to do is go into bit.ly /IT Summit 0 2003, sorry, 2001 uh, dash 03. Thank you and see you there.